My name is Gerd Masselink. I'm a professor in coastal geomorphology. I study beaches, coastal erosion and the effect of extreme storms and sea level rise on coastal environments.
My name is Alison Raby. I'm a professor in environmental fluid mechanics, and my area of research is extreme waves overtopping and impacting structures.
I think our research can contribute to improved coastal management and dealing with the challenges presented by climate change and sea level rise, erosion, those sorts of things, through improving the confidence in our forecast of where the coastline will be. And if you can confidently say and demonstrate that, in 50 years' time, this whole community is going to be completely underwater 10 times a year unless we spend £100 million in protecting it, which is not worth it. If you can convincingly bring that case, then you have something you can work with. But that uncertainty about what the future coastal landscape will look like, that is something we're working on quite a lot, and that is looking at studying the impacts of sea level rise. It's looking at the impact of extreme storms, but also how beaches recover between storms, and using that knowledge to develop predictive models that we can then apply and run different sea level scenarios for the future in different areas. That's sort of where I see the coastal process contribution to tackling these issues.
And in terms of our ageing assets around the coastline, the more we've been able to understand extreme overtopping, extreme wave impacts on those structures, and better ways of monitoring them and predicting large overtopping events, thinking about different failure mechanisms and how we can design against those. So I think that's all very important and in the mix. But
the perception that storms have become more impactful is because they are more impactful because they are now occurring together with sea level rise. So the impact has become more impactful, but the storms themselves have not necessarily become more energetic. Undoubtedly, the acceleration in sea level rise will undoubtedly enhance the influence or the impacts of storms, and increased erosion and coastal flooding will increase for centuries to come, probably. Two main things we can do about it is, first of all, we can try and flatten the curve of sea level rise and climate change, which basically means drastically reducing our greenhouse gas emissions and stopping the causes of climate change, sea level rise, enhanced erosion. But on the shorter term, we can also start adapting to rising sea level and increased impact of storms. So we have at our disposal a toolbox of adaptation tools, as I call it.
Well, the original motivation for doing the lighthouse work was concern from the lighthouse authorities about storms increasing and the effects being experienced on their lighthouses. So with sea level rising, as Gert was saying earlier, the waves will impact higher up the structure, and so they will cause more of an effect, an impact on that lighthouse. So we modelled the wave climate change over the next 50 years, and we looked at projections for the Wolf Rock Lighthouse off the southwest peninsula and also the Fastnet Lighthouse. And we've looked at 1 in 250 year extreme wave events in those locations. In fact, in this laboratory, we did a 1 in 40 scale model of the Wolf Rock Lighthouse. We can confirm that the Wolf Rock Lighthouse is going to keep standing. But one of the reasons why that is because the original engineers had a cunning design of interlinked vertical blocks through the structure. So they had a belt and braces approach to their engineered solutions.
A natural coastline will respond to rising sea level by retreating, by moving backwards and also moving upwards. As no loss of habitat, no loss of coastal ecosystem is not a problem. The problem, however, arises when we try to stop that natural movement. And then we get a real issue, which is known as coastal squeeze, which is where the different coastal environments like beaches and dunes and salt marshes get squeezed against the coastal defences. And the coastal environment can't go anywhere. And the consequence is that the depth increases, so the beaches become deeper and the salt marshes become deeper, and they also become narrower. And that is directly a loss of coastal ecosystem, loss of habitat, loss of biodiversity and natural capital.
So Louise Firth at the university has been doing a lot of work into looking at green engineering, incorporating natural habitats into coastal structures. So the situation in developing countries like Sri Lanka, they have far fewer engineered structures. They haven't followed the same curve of development. And so we are used to seeing situations of mass evacuations following cyclones, for example. I would hope that they are looking at some of the mistakes that we've made in our engineering design over the years and don't make those same mistakes. They work with the natural habitat. They consider a more holistic approach to coastal defence. Some of these locations, they're subject to many different natural hazards. So we're doing a project at the moment looking at compound flooding. So you've got the storm surge coming in, but that's coupled with the extreme precipitation.
Right.
And so when the tide is high because of the storm surge, the rivers can't actually flow out into the sea. So that's something that we're actively working on in Sri Lanka in that area.
Well, that's interesting because that affects the Thames as well, isn't it? Like the storm surge barrier closes because of the sea going up, or also because there's lots of rainfall being got rid of from the land.
And in Holland as well, I think there have been examples of some compound flooding in the States.
And you know what's interesting is that, you know, the first 10 years that the Thames surge barrier was in operation, it was used once every 2 years on average.
Right.
The last decade of operation, this decade, is used on average 3 times per year.
Wow.
So the point being, it's not because the North Sea's become more stormier, but because of the extra 20 centimetres of sea level rise makes such a huge difference.
Absolutely.
Sea level rise is not necessarily a negative thing, that is right. There's lots of environments, coastal environments, that rely on being flooded. A very simple example in the UK would be a salt marsh. The reason the salt marsh is there is because it gets flooded regularly, and that brings in sediments, brings in nutrients, and it's a good thing. And not only is that, you know, a good thing as from a coastal defence point of view, it's also very important from what's very commonly now referred to as blue carbon. It's the fact that coastal marine ecosystems can capture carbon and thereby directly reduce the carbon dioxide in the atmosphere and have a positive contribution to climate change. And we've been working in the Maldives over the past few years as well. Coral reef islands are very low-lying islands look very exposed on top of a coral reef, a living platform. And they are so low-lying that they regularly get flooded. And there's a real fear that sea level rise will result in increased frequency of flooding of these islands, and that at some point the communities will have to locate somewhere else because they can no longer live there. But people tend to forget that the reasons these islands are there, that these accumulations of coral detritus sit on the coral reef platform, is because big waves have actually dumped it there. So if you allow these islands to get flooded, like allowing salt marshes to become flooded, they are building up as sea level rises. So there's a natural adaptation strategy, I guess, from the island itself to combat sea level rise. So it's important to allow that to happen, even though it's inconvenient and potentially hazardous. We are trying to understand this overtopping process and this growing capability of the island, to study that a little bit more, and then maybe hopefully try to incorporate that into the adaptations toolbox for coral reef islands. Every country has a very large coastline, and it's impossible to protect every stretch of coast. It's just way too expensive. If there's people living there, then you have a problem. Then you'd have to somehow negotiate a way out and have come up with some sort of way to sell it to the communities that you might have to move. And I think this is where we as physical scientists have our limitations, because we can dream up a really good rational solution to a problem like that, but to implement that solution is where all sorts of disciplines have to be pulled in. Social scientists, policymakers, law, legislation, all that has to come to bear to implement those sorts of decisions. But yeah, undoubtedly we'll see an increase in sections of coastline that will be realigned or where we retreat from.
Yeah, so in the Sri Lankan project where we're looking at compound flooding, we are working with people who are specialists at engaging with stakeholders and communities. So if we want to try to engage with them and co-create a solution, we need to engage with them right from the very outset of the project and work with people who know how to engage with communities.
But local knowledge is very important, and we may have a very good generic understanding of overtopping or wave breaking or currents. But every location is different, and that local knowledge we will never have, and that local insight might always be, it would never trump the generic knowledge, I think, but it's something that should be taken into account.
I'm not convinced that coastal communities really know how life is going to change. And we haven't got all the solutions, and we don't know what people are actually going to be doing. There are more and more stories in the coastal engineering press about adaptations that are going to be required, and the funding that's going to be required as well for some of these large cities.
I think you're right from like a personal, for people's expectations point of view, but I'm slightly less pessimistic about how it will pan out, and the reason I'm being slightly less pessimistic because I've sort of looked at how they do things in the Netherlands. They've had a major review by what's called the Delta Committee to look at what is the future of the Netherlands. And they worked it all out, and the total cost for the next 100 years for the Netherlands to stay dry, so to speak, is 1% of their GDP per year. Now that's exactly the same amount as they spend on defence. I'm more worried about developing countries.
Exactly,
who will
yes.
not have
that spare 1 or 2%.
Totally. Well, they might have 1%, but their GDPs are much lower, so it won't go that far.
And I think that you also need to try to address this desire to live along the shoreline.
Yeah.
I mean, that's very much ingrained into our culture, isn't it?
Absolutely,
Just that it's the aspiration of wanting to live by the coast.
It's almost like we have a right to live on the coast.
Yes.
Yeah, and I think that's changing as well. We've been working on this concept called coastal change management areas, which is identifying areas along the coast that are likely to be influenced by sea level rise or flooding or erosion in the next 50 to 100 years. In a very sort of scientific way, mapping areas which are likely to become under threat, even though they're not under threat now.
Okay.
And then once you identify those CCMAs, these coastal change management areas, that can then be incorporated into planning policy. And it can be very clear then we should not allow permanent infrastructure, coastal infrastructure, houses or power stations in that buffer zone.
Yes.
We may allow car parks or caravan parks or temporary restaurants, but not permanent. And I think that's absolutely key because we keep burdening future generations with more cost of maintaining them by allowing planning to proceed in the coastal area.
Absolutely.
So it's about dealing with issues at the moment, but it's also preventing those issues from recurring in the next sort of generations.
Yeah.
So this planning aspect, I think, is really important too.
Yeah.